Okay, if we look at this, I did see the same answer on most of the boards with one different answer. Now, that different answer had all of this same stuff set up with a different answer here. What does that earn them on the test? If that's a 5-point problem, what did they earn for that? 4.5. Okay, because they had all the proper work done and somehow punched the wrong thing in the calculator. So that's a 0.5 point for a calculator mistake. So here we know this one was a little harder because it had sort of some hidden information in there. When you first look at this, you think, I don't have enough variables. I need 5 out of the 6. But the key here was the volume at STP. STP tells us 1 atmosphere and 0 Celsius, which is 273.15 Kelvin. So we identify our variables, convert the temperatures to Kelvin, and when we plug everything in, the 1 atmosphere or 760 torr, definition at STP, that's an exact number, so we get a new volume of 117 milliliters. Okay, so again, I think these are fairly straightforward if you're comfortable rearranging algebraic equations. So do you have any questions at this time on the small or combined gas laws, individual or combined gas laws? Okay, then the next thing we want to talk about is a couple of definitions and Dalton's law of partial pressure. When we talk about vapor pressure, we're talking about the pressure of a gas vapor that is over a container of a gas. So if I have some over a container of a liquid, if I have some liquid in a closed container, so this is sealed up at the top, as this liquid sits in there, it will eventually start to evaporate a little bit. And some of the liquid goes up into the vapor stage. After it sits for a period of time, some of the vapor starts going back to the liquid and you get an equilibrium. Now, you've experienced this. If you've ever had a sealed container of a liquid and you open it, you get that first little whiff where you can smell the vapor of that liquid. This group was talking earlier about a bottle of Jack Daniels, right? When you open that cap, you get that first little whiff of the Jack, sort of helps you start the relaxation before you even pour the drink, right? Because you have some of that ethanol in the vapor. So we can talk about the pressure that this gas has in a sealed container, and that is vapor pressure. So it is the pressure that's exerted by the vapor over a liquid. And we measure it at equilibrium when we have that liquid sitting in a sealed container. Now, we are going to use that concept to do some problems when we talk about collecting gas samples in the laboratory. So, when we talk about Dalton's law of partial pressure, it says for us in words that the total pressure of a mixture of gases is equal to the sum of the pressures that each gas would have by itself. So mathematically we can say that the total pressure is equal to the pressure of gas A plus the pressure of gas B plus the pressure of gas C, and so on. If I had 50 gases in there, I could add the pressure that each one would have by itself to the pressures of the others and get the total. So we can do some really simple addition problems with this. And when you see these kinds of things on the test, don't mess them up because they're too easy, right? What's the total pressure of a gas sample containing nitrogen at 587 torr, oxygen at 158 torr, and argon at 7 torr? Well, the total pressure is equal to the pressure of the nitrogen plus the pressure of the oxygen plus the pressure of the argon. So that's equal to 587 torr plus 158 torr plus 7 torr. we get 752 torr. Now, we can correctly report three significant figures here because we are adding these numbers, and because we're adding, we look at the place, not the number of digits. And this one stops in the ones place, as do all of these numbers, so we stop in the ones place with our answer. Okay, go ahead and do the one on the top of the next page at your seats.